And due to last time, we are over time about 50 minutes for the lectures. So for this lecture, I will try to finish it on time or early so that you can celebrate the Chinese New Year and enjoy your holiday. Okay, let's start.
Hello everyone, welcome to the course, The Programming Fundamentals. And today we will introduce the C function, which is an important feature in many programming languages. And also to make sure the quality of the online course, I will mute your microphones. And if you have any questions, please type them in the chat box. And also, answering the question one by one is not workable due to the time limitation. And I will select typical questions related to this lecture to answer. And if your questions are not answered during the lecture, I will stay behind after this lecture if you want to consult me. By
And this is a learning objective for today's lecture. After today's lecture, you will learn how to construct the program modularly from some pieces called the functions. And also, in fact, we have seen some functions before. And also, we can use some common math functions in the C standard library. And create some new functions by yourself and create our own functions. And also learning to pass messages between the functions by passing the parameters and arguments. And finally, you will learn how the function call is supported by the function call standard and the standard type frames, how the functions work, and how it's executed by the compilers. And finally, you will use the simulation techniques based on the random number generation. You will learn how to generate some random numbers in C language.
mathematics. Maintain a large program is to construct it from some small pieces, and each of which is more manageable than an original large program. And this technique is called the divide and conquer. And this lecture, I will discuss some key features of the C language and that facilitate the decision implications, operations, and the mentalities of the large programs. And functions we have mentioned before are used to modularize those programs. And the C programs are typically written by combining new functions you write with the pre-packaged functions available in the C standard library. And the C standard library provides a rich collection of functions for performing some common mathematical calculations, the string manipulations, the character manipulations, input and output, and many other useful operations. We have seen the printful, the scanful, and something like these functions. They all belongs to the packaged functions in C standard library. And also, you are suggested to formalize yourself with those rich collections and functions in the C standard library. And in order to avoid the reverting the wheel, so when possible, use the C standard library functions instead of writing your own new functions. And this can reduce the program development time, and those functions are written by the experts, so the well-tested and efficient. and use the functions in the C standard library will help make the programs more portable. We have known that we need to modularize the large programs into different small pieces, which is called as a function. And in fact, the functions, the printful, the scanful, and the power, all belongs to the standard library. And we have learned those functions in previous lectures. They are the standard library functions. And also, you can write your own functions to define the tasks that may be used at many points in a program. And those are sometimes referred to as a programmer-defined functions. And the statements defining the function are written only once. And the statements are hidden from other functions. By using the function, we can avoid to repeat set of statements. And the functions are invoked by a function call, which specifies the function name and provides the information which is known as the arguments that the called function needs to perform its designated tasks. And in a common analogy for this modularizing is the hierarchical form of the management. And a boss, which is similar to the calling function or the corner, will ask the worker, which is the called functions, to perform a task and then report back when the task is done. And for example, a function needing to display some information on the screen will cause the worker function's printful to perform the tasks. And then the printful will display the information and reports back or returns to the calling functions when its task is completed. And the both functions does not know how the worker functions performs its designated tasks. And the worker may call other worker functions, and the both will be unaware of this. And we will soon see how this hiding of the implementation's details promotes a good software engineering. And this figure shows a both function communicating with several worker functions in a hierarchical manner. And note that the worker 1 acts as a both function to the worker 4 and worker 5. And the relationships among the functions may differ from the hierarchical structures shown in this figure. We have different structures among the functions. This is an example for the both and the worker functions. And we will introduce the math library functions. And we have seen the math library in the last lectures for the example of the calculating the interest in the bank, right? And the mathematical functions will allow you to perform some common mathematical calculations. And the functions are normally used in a program by writing the name of the function followed by a left parenthesis followed by the arguments and or a common separated list of the arguments of the function followed by right parenthesis like this form. And for example, a programmer will want to calculate and print for the screen root of the 900 and you may write this statement like this. And when the statement executes the math library, the SQRT, this function, the square function, is called to calculate the square root of the number contained in the parenthesis, which is 900. And this number 900 is the arguments of the square functions, the SQRT functions. And these preceding statements will print the 13 on the screen. And this square function, the SQRT function, will take the arguments of type double and returns a type of double. And all the functions in the math library that returns the floating point values return the data type double. And note that the double values, like the float values, can be output using the 0.5 conversation specifications. And we will later see all the conversation specifications later. And also we need to include the math header by using the preprocessor directive that include the math point h when using the functions in the math library we have seen before. For the last examples, we have seen the arguments for this square SQRT functions is the consistent variables of the 900s. In fact, the function arguments may be the consistent variables or expressions. For example, in this example, if the C1 is equal to 13 and the D is equal to 3 and F is given by the 4, then this statement will calculate and print for the square root of the expressions, namely 5. So we can also remember the arguments can be the consistent variables and expressions. Here, we summarize some commonly used math library functions, and they are shown here. If you write your own functions, then you write something need to use the mathematics, you can check the slides to find the functions you want to use. And there are more math library functions here that are showing here. And you can go through the slides later when you need this math functions. We have seen some math library functions, and they are the pre-packaged functions in the C standard libraries, and is written by the experts. Now we will learn how to write our own functions. And the functions allows you to modularize programs. And there are several motivations for this functionalizing the programs. And for the divide and the cover approaches makes the program's development more management. And another motivation is the software reusability, using existing functions and building blocks to create the new programs. And we use the abstracting each time. We use the standard library functions like the print for, the scan for, and the power. And the third motivation is to avoid repeating the code in a program. The packaging the code as a function will allow the code to be executed from other locations in a program simply by calling these functions. And each function should be limited to performing a single well-defined task, and the function name should express that tasks. And this facilitates abstractions and promotes the software usability. And if you cannot choose a consistent name that expresses that the function does, it's possible that your function is attempting to perform too many devices tasks. And it's usually best to break such functions into some smaller functions. And this is sometimes called the decompositions. And now we'll talk some rulers for the functions. First, all the variables defined in a function definitions are the local variables. which means that they can be accessed only in these functions in which they are defined. And most functions has a list of the parameters that provides the meaning for the communicating information between the functions. And so we'll also learn those parameters as arguments for the functions. And then a function's parameters are also the local variables of the functions. So the variables defined in the functions and the arguments, the parameters in the functions, they are both the local variables of the functions, and they can be accessed only in the functions in which they are defined, which means that they are not visible out these functions. And in a program containing many functions, the main is often implemented as a group of codes to functions that perform the block of the function's work. So we have seen the main functions, and every program usually executed from the main functions. And the main functions is often implemented as a group of codes to other functions and performs the block of the program's work. This is a general format of function definitions. And this is the general format. We can see that the function name is any unit identifier. We have seen the identifier in the first lecture. And the return value type is a data type of the result returned to the corners. And the return value type void. We have seen that in the some variables will return the void type, and the void will indicate that a function does not return any value. And together, the return value type, the function name, and the parameter list are sometimes referred to as a function header. And checks that your functions that are supposed to return values to do so, and checks that your functions that are not supposed to return values do not. And each program we have presented has consists of the function called the main functions. And the main that called the standard library functions to accomplish these tasks. And we now consider how to write the custom functions. There is an example that consider a program that uses a function square to calculate and print the squares of the integers from the 1 to 10. And how can we write these functions? Here is a program for these examples. We can see that first we'll also include the standard in.
Maybe first we can type this code in our IDE, and then I will explain this code and how we define and decline a function. And in this example, we need to output the square root, the square of the number in the range of the 1 to the 10. So we write our all functions the square, which name is a square to calculate a square for an integer. First, also include this standard input and output header, because we will use the print4 function, which is in the standard input and output header. And now we will write the function prototype for the functions, and the function prototype will be explained later. Now, you can just remember that for every defined functions, we need to write its function prototype before this main functions, before we use this function. And now we use the four statements because we know the number of the iterations is 10. Now we can write the body of these functions. Each time we need to print for the number of the square of this input integer. And we can assume that we have a function and this function coded square, and it can help us to calculate the square of the integers. So we can just call these functions. And then we'll put a new line. Now we have assumed that we already have this function called the square to calculate the square of integers. And now we need to define these functions. First, we have known the general format of the function, and this int is a return type for these functions, which means that these functions will return a value, and this value is an int type. The square is a square root defined in the math. I see the Kavil has asked a question: why isn't it a square function, sqrt? Because the sqrt is a defined function in the math library, which is used to calculate the square root of a function. Now we define, yes, they are different. And now we are learn to define our own functions. And the square is the math library functions. Okay, this function is very simple. It will give an input, which is an int type. It get an input which is arguments y, and which has an integer type, and then we can return its square for this integer. Okay, so we can now run this function, run this code. Maybe we open a new, define the function, the line. Yes, for the line, the 14 to the line 16 is used to define this function. And this is the function prototype. Okay, maybe we try this. And we now check why the code cannot be successfully built. Because those two things. And now we can successfully run this code because I defined this function again in other C code, and so it will find this function has already been defined before. Why? What will happen if we do not write the line? We do not define the function, then we cannot find the functions. So, for example, now we can first see this successful run code. Maybe we print. It's not a reason here. You can put something, some number before. Maybe I recreate a code. No, because the output of our IDE do not showing here. Maybe I. Maybe I will open this. Sorry, I don't know why there is no output showing here. Maybe I open. Do you know why there is no output? The output are not showing in this IDE. Maybe we create a new one here. And let's see. What? Okay, let's try this. Okay, the results are showing here. And we now retype this code. Maybe because of this project, I include other things in this project and it's not clean. So I recreate one. Now I will type this. Yes, the code is correct, but the project in the IDE may include other things. And now we type and run it again. And we can see the result here. Now we can ignore this return, and I will explain why we need this, why we do not need this return 0 in the main functions. And now if we want a new line, so we should include the puts. Okay, now we can see this program has a right results finally. And for your questions, what happened if we without define a function from Zhekai here? Now, if we comment this function, so the compiler, when the compiler needs a link different parts of the code, it cannot find these functions. Then it will give an error. We can see. We can see that we cannot build this code successfully. And also we can see the math library we have introduced before here. And we can print for the value of the square root of x. Okay. Because we need to open this. And we can see that we can get the square and the square root of this code. And it's worth note that we define the function square, right? But we did not define the function, the square root. However, we can directly use these functions because it has been defined in this header. So we must include this line when we use the square root functions. And there are two types of functions: the prepackaged functions in the standard libraries, and some experts have helped us to write the correct functions already. So we can just use it, like the square root function here. And also we can define our own functions. And in these examples, we define our own functions square here. So there are two types of functions we can use. Yes, because the square is not included in the math library, so we must define it. And also we have the power functions in the math library, right? So we can also use the power functions to replace the square functions. In here, for this example, I just want to tell you that we can define our own functions for implement some functions that has not been defined by the standard library. The put functions is to output the string, the messages, in these two signs, and also input a new line. And what you meaning, Zhiqiu, we can define it anywhere in the code. We cannot ignore this line from to define our own function square, because the square function are not be defined in the math library. Yeah, you can type these functions before this main function is also behind this main functions, but you cannot define these functions inside a function. For example, the main function is also a function, so you cannot define another functions inside a function. Why we need to print 4? Because in these examples, I print the square of our integers and also print its square root of this integer. I want to see it again that we cannot delete those lines because the square functions here we used are not defined in any protected library. So if we use this square function, we need to define it. Also, you can use other names such as my square or something else. You can also use other name, but your name must have some meaning. Okay, do you have any questions for this first simple example of the function? If not, we will continue. Can you explain why the y is the output as you see the output is square x? You mean why it can implement the function of the square? Because in this function square, it will accept an input, right? It will have one argument, and this argument is y. And for every y input into these functions, we will print its square because we calculate its square here and then return it to the corner. So to create our own functions, we first need to type the function prototype, and then we need to return the value. Later, I will explain why we need to include this function prototype. In fact, the function prototype help us to check whether we input the right type of the data and the right number of the parameters. Can we define the square first? I mean, can we define the square first? I mean, can we remove the 9 to the? Yes, we can remove it. In fact, we can input the function definitions in anywhere. However, such as in front of the main functions. However, in fact, the main function is also a function, right? We cannot define a function inside another functions, inside other function. So we can define the function here outside this function main. However, we cannot put this 9 in here. So we can define a function everywhere. However, we cannot define a functions inside another function. What if the function is completed? Should we return twice or something? Sorry, I don't really understand your meaning. Do you mean that sometimes you need to return multiple values? Instead of a single value? Yes, maybe we can try it, such as we return y and also return. In fact, if you want to return, we can only use the return once. And if we want to return multiple values, we will use the array or other data structure, and we will introduce it in our future lecture. You cannot return 2 times, such as here. Assume you write the 2 return, right? However, when the function meets the first return, then this function will be executed. So after it executed this element, then this function is finished, and the result has already been returned to this corner. So if you have multiple returns, then only the first return will be really executed. And if you want to output multiple values, then we have other techniques to help us, but we do not learn it in this lecture because we will use some data structures or the array. Both the function prototype and the definitions of the functions must be outside the main functions, and also the prototype of the function usually is in front of the main function. They cannot be anywhere in the compiler. They can be anywhere in your C code. In fact, they can be the other C file, and you can also include it. And I will give an example later. So right now, you just to know that you should include those prototypes in the same C file with the main function. I will talk about why we need the return 0 here. In fact, the main is a function, right? The main is also a function, and the return type of the main function is int. So we need to return some int values for the main functions. And why there is a return 0 and why we do not include the return 0 here, we will talk about it later for this main function in this lecture. So if you have, yes, it's used in the early C versions, and we will explain the 0, what's the meaning for the 0 for the main function later.
An output header, because we will use the print4 functions, and the print4 function is in the standard input and output header library. And also, now we will end our main functions. Now you can first ignore these statements. Then we will end our main functions. We have seen the main functions before, and then we will use the 4 statements from the 1 to 10 to print the screen of the number in 1 to 10. Then we will define.
We have another question. Can you clarify why the becomes output at x is used? Yes. We input x here, right? So this line will tell us you need to call this function to call the square function, help us to calculate the square of the x. So here it will use this square functions when it executed at this line. First, it will give a copy of x to y, and then calculates the y, the square of y. Remember, the y is a copy of x when we input the x to the square function. And then it will return the value to the corner, to here. So we can print for the results. We will have a copy of y. The x and y are not the random variables. In fact, the x is local variables we defined here, right? And the y is the local variables for this function itself. Such as we write some functions in mathematics, such as fx, right? And in fact, the x can be any value. If we have a function, if we have a mathematical function fx, and equal to the square of the x, we write the function like fx. However, when we input a value to the x, such as we're giving the x as 1, then we can calculate this value of the functions is 1. Or we can giving the value of this x is 2, and then we can calculate the value of the functions is 4. So this is define the function, how the functions work by giving the variable y. And here we put the value of the x to the functions. So we will have a copy of x as y for this function. Yes, we can replace y with any other variables. Why I use y here, do not use the x? Because I want you to distinguish those two variables. In fact, these two variables are different. This is a variables in these functions, and this is a variable in this for statement. So I use a different character here for you to distinguish those two variables. So it's more likely a symbol, and it's a real, and this x will more like a real number in our mathematical function. Yes, such as we can define it as yy. And those two variables are different. And every time we call these functions, we will copy a value of x and to assign the value to the yy in this function. Do I answer your question? And do you still have questions for these two different variables? We can also use x here, but those two x are different. In fact, this function cannot see the x here, and also this x cannot see the other x here. This x is a local variable for these four statements we seen before. For example, we even cannot print for the x here, right? We have talked about last lecture. So this x is only visible inside the four statements. And same as this x, and this x is also visible in this int, in this square function. Do you understand the difference? The difference for those two variables? Okay, great. So it can be other characters and other name of the variables. And remember, those two are different.
Is the square to calculate the square of x each times. And the square functions are definitions is showing here. Our square functions will, the name of this function is a square, and its parameters is a variable called y, which is an int type. And then we will calculate the square of y, and the results of the square of y is still an int. So the return type is int here. And then we return the value of this. We return the value of the square of y here to the corner. And in order to help the main function to find this function square, we need to use this function prototype here. And then we'll talk about the function prototype in more detail. And now you just need to remember that in order to find these functions, you need to first giving the function prototypes first before these main functions. Now we will continue explaining these functions. First, we have defined a function called the square, right? And the name of the function is a square, which is invoked or coded in the main functions. We have seen in the main functions we called the square functions within the printf statements. In fact, the statements are showing here. In the for statement in the main functions, we use this statement to call the square function and then print the value. Use the printf functions. And first, the function square will receive a copy. Remember, you receive a copy of the value of the x in the parameter y. In fact, we do not directly pass the x to this function. We just create a copy. And then the square will receive a copy of this value x in the parameter y in its own functions, the parameter y. And then the square will calculate the square of the y using this expression. And then the result is passed back, returned to the function printf in main, where the square was invoked, and the printf displays the results. And this process is repeated 10 times using the for statements.
So, do you have any questions for the execution for this in this example? Do you know why this? Do you know why this code can output the square for the repeat can output the square for the 1 into the 10? For example, at the first time, we enter the main functions, and then we go to the for statement, right? So at the first time, the x will equal to 1, right? And when x equal to 1, it tells us that you need to call this function square to calculate the square of 1. So it will use this function to calculate the square of x, the ones. And the second time, the x will equal to 2. And it also it again record the square functions again. And however, this time the x is 2. So it passes the 2 to these functions to calculate the square of 2. So the whole picture of this example is to calculate the square of x with respect to x is between 1 to 10. And how can we calculate the square of x? So we use these functions to calculate the square for x. And the copy of x is help us to know how this function is coded by the corner here. So do you still have any questions about how the function is coded by the corner? You can see the function as a 2, and every time you just need to call this 2 to ask this 2 to help you to do some calculations or to execute some functions. And this is this corner here to call this function. And after the function is executed, it will return the value to the corner. So we can print for the value of the corner. The print4 did not call the square functions. These expressions call these functions to execute call the functions to calculate the square of the x, and these three lines are defined how we can calculate the value of the square for an integer. In fact, we can write this like this, such as the int z equal to square x, y. And then we just need to print for the z. So in this statement, it will call these functions. It will call the calculations.
And this is explained for the whole functions and how the functions it works. And we select some part of this program which is related to the square functions, those two parts, as shown in the slides. We can see that the square, the functions x express integers, parameters y. So when you call the square functions, you need to input integer values to the square as its parameters y. And the keyword int preceding the function's name, inducting that the square will return an integer result. So those two integers are different. The first integer here means it needs an integer parameters y, and those integers which is preceding the function name indicates that this function will return the integer value. And also the return statement in the square will pass the value of the expressions, the whole expressions, back to the calling functions. This is the return. Return means it will return the results of the expressions to the calling function. And this process is repeated 10 times using the four statements.
So these two int are also different, right? This int it tells us that you should input a parameter whose type is int, and this int tells us that you need to return an int type. So this is the input, the parameter arguments, and this is output, the return. And those two int are different. Also, if we input a double to the functions, what will happen? For example, we will convert the int x to the double. We can see what will happen. It shows error here. We can see that there is error because we have the unexpected expressions. And we run it. We can see we can still get the right answer. However, we input a float type, right? So in fact, in a function, it will convert the function, will convert the type to the correct type. And we will talk the details later. So here, remember, the input type should be the same as the needed type in the function. Because it will return the integer type, and the d is print for the integer type. This value will become the return value. Here we'll print for the returned value, and the returned value is an integer type.
Also, we can see the general format of the function definitions again. We have seen it before. Now we have seen it.
For the output, for the printf, we will not lose any data because its output is int type. However, for the int, here we will lose some from a functional part. However, for this printf, we will not lose any data because output is an integer type.
Examples for the functions, so we will have a more we can have a more better understanding for these definitions. Remember the function name we have seen before. Here is any valid identifier, and the identifier is, we have talked about the identifier in the first lecture. And the return value type here is the data type of the result returned to the corner. And in the last examples, our return value type is in the, so we type the int here. And also the return value type, if the return value type is a void, we can write the return value type as a void, which will mean that the function does not return any value. And together, the return value type, the function name, and the parameter list are sometimes referred to as a functional header, just like the for statement header. And this is the body of these functions, the other parts. And the parameter list here, which is arguments, sometimes is a comma separated list that specifies the parameters received by the function when it's called it. And if a function does not receive any value, then the parameter list is a void. And for the main functions, we have seen that we input the parameters, the list as a void. So which means that the main functions do not need any arguments. And finally, the definition and the statements within the braces from the function body forms the function body, and which is also known as a block. The block is a part which is inside a pair of the braces. We have seen it at the second lecture. And the variables can be declared in the any block. So some local variables that are used by these functions can be declared in any block, and the blocks can also be listed. For example, we can, for the example in the fourth element, and we listed some block. And there are three, we have seen that we return some values. For example, in the last example, we return the calculations for the screen of integers to the calling functions. In fact, there are three ways to return control from a called functions to the points at which a function was invoked. And if the function does not return a value, then the control returned immediately will after the execute of the function body. And if the function does not return a value, and the control is returned simply when the function ending right braces is reached, or by executing the statement return. So if the function does not return the result, we can also use this statement return. And also, if the function does return results, and the statement return the expressions, will return the value of the expressions to the corner. And notice that the main have a int return type, right? Our main.
Okay, now we'll talk the return for the main functions, and some of you had asked the questions. So in this lecture, in this slide, we will explain why the main need to return the 0, and why we do not write the return 0 in our program.
Functions. And the power, we do not write the return 0 in the main functions. Why? Because the return value of the main functions is used to indicate whether the program executed correctly. And in the early versions of the C, we explicitly place these statements: the return 0, the statements at the end of the main functions, to indicate that a program can run successfully. And the C standard indicates that the main implicitly return 0 if you remove these statements, as we have done before in the previous lectures. We do not write the return 0 in the main functions, and the main functions will implicitly return the 0 if we do not write these statements. And also, you can explicitly return non-zero value from the main functions to indicate that a problem maybe appears during your program's execution. And for information how to report a program failed, you can see the documents for your particular operating system environment. It's different for different operating system environment. This is our second examples. We will use programmer-defined functions maximize to.
The explicitly means that we need to write this line in our this return 0 in our main functions. And the implicitly means that we do not write this line in our main functions. However, the compiler will help us to write this line when it compiles our function, our program.
The main functions will implicitly return the 0 if we do not write these elements. And also, you can explicitly return non-zero value from the main functions to indicate that a problem maybe appears during your program's execution. And for information how to report a program failed, you can see the documents for your particular operating system environment. It's different for different operating system environment. This is our second examples. We will use programmer-defined functions maximize to determine and return the largest of 3 integers. So now you can try this program by yourself. Those 3 integers are passed to the functions.
So you can try to solve this problem by yourself. I write some main body of this program, and now you need to write the function, the maximum, which is determine and return the largest value of 3 integers. So now you should to write the function definitions by yourself. Maybe I give you 3 minutes. And then we will together to solve this problem and write the functions together. If you finish it, you can type it down on the screen, on the chat box, to let us know. Do you finish this function, the maximum? Great. I see that Carville has done this task. Maybe we can now write it together. Jason, for your first element, you use a float. Change this float to int. Now let's write this function together. And we can talk about the assignment later, maybe after this lecture. Now we write this function. And the input of the function is x, y, and z. Right. And we need to output the largest one of the three. So first, maybe we can define a variable. And for example, the max. And we first assume that the max number is x. And if the max is less than y, which means that y should be the largest value, and y is larger than x, right? So we could z. So right now the max is already the value of the large one between the x and y. So we only need to compare the max with z. And then we can return the value of the max, right? And now we can run this code and input 3 value. And it will give us the largest one among those 3 integers. And do you have any questions for this function? Yes, you directly use the x and assume the x is the largest value among the 3 integers. And however, for the readabilities, it is better to define a variable called the max. I believe your functions can also get the correct answer, but for the readabilities to help others to understand your code, maybe you can use a new variable called max. Of course, your version is also correct. Yeah, Dongyang gave another version of this code. In these cases, you need to enumerate all the situations for the x, y, and z. For example, if they are equal, Dongyang, maybe you can check your code, your logic in this code again. Yes, we must include this sign besides the prototype of the function. Because it's also a statement. So we need to include those signs. Yes, we should add it in the end of every statement.
Maximize, and then which will determine the largest value, and this value is returned to the main functions by using the return statements in these functions. So now you can try these functions by your now. This is
and the line sorting is ahead of this main function. It's just a head, same as this head. And this is define a function, and this is function header, and this is the body of these functions, which consists of some statements.
Except for the main body, the definitions of the functions. And now you need to write these functions to make.
Because this line is not a statement. It tells us that, oh, we define the functions, and this is the head of the function. Then we will, this is the whole body of this function. So this none is not a statement.
All programs works. Here,
in fact, a function consists of a header and the body of the function. And this is a header of the function, and this is the body of this function. And the body of the function may consist of many statements and the definitions.
Body of these functions, and we can see that we have input the three integers in the to the parameters, pass three integers to the functions. They are x, y, and z parameters, and they are also known as the arguments. And first, we will define a variable max, and decline and define and assign the value of x to the max, because now we assume that the x is the largest value among the three integers. And now if y is larger than the x, larger than the max value, so we should assign the value to the y to the max. the max value. And now, after we executed the statements, we have known that now the max is already the largest value among the x and y. So now we just need to compare z with this max value. If the z is larger than the max, then we could assign the z to the max value. Finally, we can return the variable's max, which is already the largest value. So these functions can implement the functions to determine and return the largest of the three integers. And we have seen the function prototypes before in the last two examples. And for the last example, the function prototype is at the 9.5. And an important feature of C is the function prototype. And this feature was brought from the C++. And the compilers will use the function prototypes to validate the function calls. And it states that the maximum functions takes the three arguments of the type int and then returns a result of the type int. And notice that the parameter names in the function prototypes for documentation purpose, and the compilers will ignore those names. So the prototype like this, the int, the maximum, the int is also valid. And a function call that does not match the function prototype is a compilation error. And an error is also generated if the function prototype and the function definition disagree. For example, in this figure and in the slides, if the function prototype had been written like this here, then the compiler would generate an error because the valid return type in the function prototype would differ from the int return type in the function header. So remember, the function prototype should be consistent as a function header for the function definitions. And another important feature of the function prototypes is the conversion of the arguments, which means that the function will forcing the arguments to the right type. For example, the math library function, the sqrt, the square we have seen before, can be coded with the integer arguments, even though the function prototypes in math.h specifies a double parameter, and the function will still work correctly. So what it happened? The function prototype caused the compilers to convert a copy of the integer value 4 to the double value 4.0 before the copy is passed to these functions. And in general, the argument values that does not correspond precisely to the parameter types in the function prototypes are converted to the right type before the function is called. And those conversions can lead to incorrect results if these usually arithmetic conversation runners are not followed. And those runners specifies how the values can be converted to other type without losing the data. And if there is no function prototype for a function, then the compiler will form its own function prototype using the first occurrence of the function, either the function definitions or a call to the function. And this will typically lead to a warning or errors depending on the compiler. And in our examples, our square examples above, an int is automatically converted to a double without changing its value. However, a double converted to an int will subtract the fractional part, will lose the fractional part of the double value, so it will change the original value. It will make the rate maybe not correct. So converting a large integer type to a small integer types may also result in a changed values. So you need to do it carefully and use the cluster operators we learned last lecture to correctly convert the value in different types. Here, we summarize some common conversation specifications. Many of you ask about the conversation specifications, and they are be summarized here. And this is print for conversation specifications, and this is scan for the conversation specifications, and this is data type. You can, when you print or scan for your own data, you can find its corresponding conversation specification to write and to use to form the correct format string. We have known that how to write your own new functions. However, how the functions are works in a C programs, why the C can call the functions to execute. So to understand how C perform function calls.
Let's see some questions. The last slide, the void for the max. The void is wrong. We do not use the void in this example. The type for the maximal is int here. However, if we change this int as a void, such as like this, then we will get an error because the function body, the function definitions is different from the function prototype. And those two should be consistent. So the void will, if we change the int to a void, then we will get an error. Do you mean this void? No, you can use the void if you do not need to return any value. So you can use the void, and if you use void, then there should also be the void. For this example, I just want to tell you that those two, the function prototype and the function head, should be consistent. You cannot use the void in the function prototype. However, use the int in the function header. In this case, it will be wrong. Okay. Jason, maybe we first skip your questions, and after the lecture, we can talk about it. Could you demonstrate how to use the conversation specification in one program? For example, the percent sign D is a conversation specification. And also, here is also the conversation specification. I just list all the conversation specifications for different data types. So you can search a table to find the corresponding conversation specification when you need. Yes, only for the long dub, the L is in the capital letter. Okay, maybe we can continue. Next, we'll talk how the compiler to execute the function, how those functions are organized in a program. Behind the screen, we just see that we define a function, but how the compiler indeed uses function and organize those functions, we will talk in these 2 or 3 lecture slides.
We first need to consider data structure, known as a stock. And the data structure is a collection of the related data items. And we can think of the stack as a pile of the dishes. When the dishes is placed, then it's normally placed at the top, which means that we can refer to as pushing the dishes on the stack. And similarly, when the dish is removed, then it's normally removed from the top, which referred to as the popping to the dish of the stack. And the stacks are knowing the first in, the last in, the first out data structures. And the last item we pushed while on the stack is the first item popped from the stack, which means that when we take a new date, then we usually put this new date on top of the stack. And then we need to, if we need to remove data, then we also remove the data from on the top of this stack. So the stack is a last in, first out structure. And there is an important technique for us to understand is the function call stock, sometimes also referred to the program executing stock. And this data structure working behind the screens, which is working behind the screens, we cannot see the working process. Suppose the function call and return. And it also supposes the creation, the maintenance, and the distraction of each called function's local variables. And as each function is called, it may call other functions, which may call other functions all before any function returns. And each function eventually must return control to a function that called it. So we must keep tracking of the return addresses that each function needs to return control to the function that called it. And the function call stack is a perfect data structure for handling these informations. Each time, how it works in particular, each time a function calls another function, then an entry is pushed on the stack. And this entry called a stack frame and containing the return addresses that the called functions need in order to return to the calling function. And if the called function returns, then instead of calling another functions before returning, the stack from where two for the functions call is popped, and the control transfers to the return addresses in the popped stack frame. And each called functions can always find the information it needs to return to its corner at the top of the call stack, because the stack is last in, first out structure. And if a function makes a call to another function, then a stack frame for the new function's call is simply pushed onto the call state. Therefore, the return addresses required by the newly called functions to return to its corner is now located at the top of the stack. And the stack frames have another important responsibilities. And most functions have the automatic variables, the parameters, and some of the all local variables. The automatic variables will need to execute while a function is executing, so they need to remind the active if the function makes calls to other functions. But when a called function returns to its corner, the called function's automatic variable needs to go away. So the called function stack frame is a perfect place to receive the memory for the automatic variables. And that stack frame will execute only as long as the called function is active. And when that function returns and no longer needs its local automatic variables, its stack frame is popped from the stack. And those local automatic variables are no longer known to this program. And of course, the amount of memory in a computer is infinite. So only some amount of the memory can be used to store the stock frames on the function call start. And if more functions calls appear, then can have their own stock frames stored in the function's call. And then an error knowing the stock overflow will appear. Now let's consider how the call stock supports the operations of the script functions called by the main function. We have seen these functions before. First, the operating system will call the main functions, right? We start from the main functions every time.
Every time we will start the main functions, to execute it from the main function. So now the operating system is executing starts from the main functions. What will happen for this main function?
And this pushes a stock frame onto the stock. Now,
so we have a stock, and initially the stock is empty, and nothing in the stock. And when we start executing the main functions, then the information about the main functions, the stock frame, the frame included the information about this main functions, which will be pushed into the stock. So in the stock now, it will have one data, which is the function frame, the stock frame here.
Stock is here, this dark blue, and the stock frames tells the main how to return to the operating system. That is transfer to return the address to the R1 here, and containing the space for the main automatic variables, such as the A, which is initialized to the 10. So the information about the main functions and the variables are stored as a stock frame. And then the stock frame is pushed onto the stock here. And the function main before returning to the operating system, now the calls function the square. Now it calls the function square. This will cause a frame.
Now we have executed in this line, so it will call this function square. What happened in this step when we call this function square?
A stack frame from square to be put.
So in this step, we will have another structure frame for the square function here, and we also again put this frame, put the information about the square functions into the stock.
Onto the function called stack, and this stock here is called the function. Then it will call another. It will have another stock frame be put in the stock, and this stock form will contain the return addresses for the square needs to return to the main functions, and the memory for the square's automatic variables, the x here. So at the first step, the stack frame for the main functions will be pushed on the screen, on the square, one are stack. And then the second step, the functions, the square, the stock frame of the square will be pushed into the stock. So after the first two steps, we will have two stock frames in the stock. Call step functions.
And after the square calculates the square of the, after the square has calculated the square of its arguments, then it needs to return to the main function, and no longer needs the memory for its arithmetic variables here. So the stock is popped, and the stock for this function square is popped, and giving the square the return occasions in the main functions here. And there are two, and it will losing the square's arithmetical variable. And this figure shows the function call stock after square stock frame has been popped. So here we only has one stock frame for the main functions. And the function main now will display the results of the calling square and reaching the closing right braces of the main functions, and will cause its stock frame to be popped from the stock. And giving the main address, it will need to return to the operating system. So after this step, and this main function frame will also be popped, and then our executing for this program will be finished. And it is not the flowchart. It's to help us know how different functions are organized by the container.
Next, we will introduce the header. We have seen the header many times from our first lectures, the standard input and output header. And in fact, each standard library has a corresponding header containing the function prototypes for all the functions in that libraries, and the definitions of various data types and consistent needed by those functions. And those table list some of the standard library header that may be included in our programs. So when your program need the corresponding functions, you can include the corresponding header by search this table. And there are more headers are showing here, some commonly used header. Later, we will see how to use the time header. Of course, you can also write your own header. Next, I will give an example. You can also create some custom headers, and some programmer definited headers should be used point H, the file name. So a program definition header can be included by using the include preprocessor directive. And for example, if the prototype for our square functions was located in a head square H, this file, and we'd include the header in our program by using the following directive at the top of the program here.
So in these examples, I show you how to use your own defined header. For this example is another example square we have seen before, and our original version is here, right? If we remove those comments, then it will be the version we have seen before, and also delete this line and delete those comments. And how can we to define a function in a header, which is shown like here. For example, we can have a square point h file, and it is our header. And then we can write the function prototype in this square point h file, like this, showing on the second figure here. And those if not defined square point h and defined square h is runners. You must write those line in the header, your all defined header. And also you need to define another file, which is a square point c, showing on the third figure here. And in this figure, you should include your square point h and also give the definitions of the function, showing in the line from the line 9 to the 11. And then in your main functions, you can simply include your all header and just use the functions square, not to define it again, because it has been defined in your square point c file. So in these examples, we divide this our all versions of the program into 3 files: the original one, the main function, the main file, and the square point c and the square point h. And in square point h, you need to write the function prototype, and in the square point c, you need to write the definitions of the function. So do you have any questions for this customer header, your all header? Yes, we need 3 files. Of course, we can only use 2 files, and we can remove this file, this third file. However, in this case, we need to write the definitions of the functions in point C. So a good practice behavior is to use the 3 files. Of course, this is just an example for you to help you know that we can define our own headers. And because our program is very simple, this is a very simple example. So you can write the function definitions and the function prototype in 1 file. It's okay. It's just an example to let you know that we can write our own header. If no more questions, I will continue. A new header needs to create a new file, right? A new header, it is better to create a new file. Of course, you do not need to create a new file. Then you need to write the function definitions in the main point C file. However, it is better to create a new one. It's a good programming behavior. First, define a header here, and then define the function in another file. Yeah, the second file is a header, so its name is the square point h, and the h means the header, right? Yeah, the meaning is if not defined the square header, then we should define the square header. So when you define your old header, you just use those two lines, those three lines, and change those change this as your file name. The middle file is a header, the square point H, same as a standard input and output H. If you look at the file for the standard input and output point H, you can see they also have some similar codes like this. Yeah, end if means that we end the if for these two. So in your old header, remember to include those three lines. The end if is for this if. And it's not a C language. You just need to include the three lines. And change this as your file name. And then write your function prototype here. Okay, do you have any questions, more questions about this header? Why there is an int square in the middle line, in the middle file? It's a function prototype. So in the head file, the point H file, we include the function prototype, and in the point C file, we include the function definition. Yes, we can define more than one prototype in a header. Right, it's right. For example, in the math library head, it includes many prototypes for different functions. And also in their C file, they will write the multiple function definitions for each function prototype. And all these functions are belongs to the mathematical calculations, so they are in a same file. Yes, here we just divided the whole examples into three files to help you know to demonstrate you that how to define your old header. If you open the other header, such as the math header, you can see many prototypes, many function prototypes. If it's a very simple examples, for example, our examples, you can only write in one file. It's okay and it's correct and it's a best choice. However, I just use this example for you to understand how can we divide a program into multiple files and how can we define our header. So for example, for the math library, because it has many functions, so it cannot just include all the functions in your main point C file. So they use multiple files for different functions. We have talked about the prototype, the function prototype before. We can remove the variables for the prototype. They are same. So maybe you can refer to the slides, maybe the slides about 10 slides before. We can remove the parameters in the prototype. So we may have a lot of files to introduce. Yes, if your program is very complex, so you can include multiple photo type, multiple headers to introduce a photo type. This sign is a runner. This sign means that you should use this sign and include the header. It's a runner. Okay, do you have any questions for this slide? If your problem is very simple, you just use one file, it's okay. This example is just to tell you that you can divide the files into multiple files. It's just an example for learning the header. Okay, if no more questions, we will continue.
Now we'll talk about how to pass in the arguments between the functions. We have seen that we have passed the variables in the main functions to the square functions. And how can those passing are implemented? Is implemented. And in many programming languages, there are two ways to pass the arguments. They are the pass by the value and the pass by the references. And when arguments are passed by the value, a copy of the argument's value is made and passed to the coded functions. And the changes to the copy does not affect our original values, variables values in the corner, which means that we input x to the square functions, but the x in the main functions, the value of the x in the main function will not be changed. And when argument is passed by references, then the corner will allow the coded functions to modify the original values, variables value. And pass by value should be used whenever the coded functions does not need to modify the value of the corner's original variable. And this prevents the accidental side effector, the variable modifications, that so greatly hinder the development of correct and reliable software system. And passed by references should be used only with trusted coded functions that need to modify the original value. And in C, all the arguments are passed by the value. And in chapter and in lecture 6, we will see that the array arguments are automatically passed by the references for the performance reasons. We have learned the functions in the pre-packaged standard libraries and how to write our own functions and how the functions works and executed by the compilers. Now we need to learn how to generate some random numbers in C. Why we need to learn how to randomly generate some numbers. And for example, if a program that needs us to simulate the coin tossing requires only the one and the two variables randomly. And also, for example, DC rolling programs that will simulate 6 sides die, they would require randomly numbers from the 1 to the 6. And the random functions generator will generate integers between the 0 and the random max, which is a simplified consistent defined in the standard library header. And the standard C will state that the value of the random max must be at least the max value for the 2-bit integers. And the programs in this this program be tested on the Xcode with a maximal the random max value of the max value of the 2-byte integers. There may be different compilers, and different compilers will have different random max values. So you can check the random max values in your own environment. And if the random, we can generate a random value by calling those random functions like this statement. And this statement will help us to generate a random value and assign a value to the variable I. And if these rand functions can truly produce the integers at random, then every number between the 0 and the random max has a equally chance or the probability of being chosen each time the rand is called. And the range of the values produced directly by the rand functions is often different from which needed in a specified applications. For example, the 2 cases we talked before. And for the example of rolling a 6-side to demonstrate random functions, let's develop a program to simulate the 20 rows of the 6-side data and print the value of each row. And the function prototypes for the functions is in the standard library head, and we can use the reminder operators here in conjunction with the random functions as follows to produce the integers in a range the 0 to the n-1. If we set the n as a 6, so we can get integers in the range the 0 to 5. And in fact, this process divides by using the reminder of the random value, where it's called the scaling. And the number 6 is called the scaling factors for our last examples. And also, we can also use the shifting operators. The shift the range of the numbers will be produced by adding the value A to the generated random numbers. So we can get the random number between the range m and the n plus m and minus 1. This is our code for the shift scaled random integers produced by the random functions, and we randomly generate the random number 20 times and see the result. And after if the counter is divisible by 5, we will begin a new line of the output for the better readability for the output.
Now I type this code in IDE, and this code we will input the random number 20 times using the rand function in the standard library. And each time I will print for the random number. We generate a random number, and then we get the remainder of 6. So we can get a random number in the range from 0 to 5. And then we add a 1, we plus 1, which means that we can get a random number whose range is between the 1 to the 6. And every 5 steps, we will input a new line for better readability. Okay, and it's wrong, it's code. We can see this is the number we generated. We generate, and we can run it again. Okay, do you have any questions for this example? Do you have any questions for this example? If not, we will continue. Yes, for example, okay, if we remove this, right, if we just use this function, then we will random number, random integers in an int type and in an unsigned int type, unsigned int type, which is an integer. This is the max number of the random number using these functions, random max, and you can check random max in by print for its value. So if we do not use this sign, you do not use the remainder, then we will get a random value from the 0 to the max round, to the max value. And do you remember the remind sign before? We talked about this remind operators before. So if we use this remind operator, then the reminder for the 6 can only be the 0, 1, 2, 3, and 5, right? So the range of the random number will change to the range 0 to 5. So we can change the max number of random to the 5, right? If we use the 6, then the max random number is 5. And then we add 1, we plus 1, because we want to the random number from 1 to 6. So we can add 1 before this random number to get a random range from 0 to 6, or from 1 to 6. Yeah, well, if we use 7, so we can get a range from 0 to 6 to 0 to 6, right? But in this example, we want to get a random number in a range of 1 to 6. If we type the 6, then we will get the range 0 to 6, right? If we get it's not matches our requirement for this example. So do we have any questions for this this scanning? So this called it a scanning, which can scanning the range of a random number, and this called it a shift. It can shift the range from 0 to another number, and in this case, the number is 1.
This is another examples. And you can try to write this program by yourself first. And we will running a 6 sites many times. And you need to count how many times each side is selected, and then print the number for each type, print the number for each side.
This example is just to combine the for statement with the switch statement and a random and the random function. So it's a very simple examples, which consists of some important feature we introduced in this lecture. And now I will skip these examples, and you can it's really a simple examples. If you go through this code, you can simply know how this code works. So at this time, I skip these examples due to the time limitation. And you can check this example after the lecture. I believe that everyone can simply handle this example. It's just use a random function to get a random number between the 1 to 6, and then judge and then count the number of the number be appear in this four statements. Okay, so we skip it now. Okay, this slide will tell us an interesting story. And we generate a random number, but it's really a random number. So see the slides, you will get the answer.
And we have learned that we can use random functions to randomly generate a number. And we now let's executing the programs for the examples multiple times. And they see.
For example, this is our example. Last example, I run it. Okay, and this is our result. Now I will keep those results. For example, I write those results here. Here, right? And then we can run this program again. Let's see. We can see our second run gets the exactly same result as our first run. However, it's a random number. If every time we run the code, it gets the same result, how can we see it is a random number? It's a random generation, right? If it's really a random number, then each time I run the code, it will randomly generate. So, yes, you're right, Kevin. They are the fake random numbers. In fact, we call it as the pseudo random numbers. And I will tell you how to generate the real random number and why we get these pseudo random numbers here.
Result. We can see that the executing the program of the first examples again will produce exactly the same sequence of the values. So it's not really random numbers, right? We run it again, the results is exactly the same as the sequence of the value. So how can those be the random numbers? Those repeatedly is important characters of the function render. So when debugging,
so why we need the program to generate the same result for different run? The reason is
a program this repeatedly is essential for providing the correlations to a program work properly. However, the function randomly actually generate the pseudo random numbers, and calling repeatedly produce a sequence of the numbers that appears to be random. However, the sequence repeats itself each time the program is executed. Once the program has been debugged, it can be conditioned to produce a different sequence of the random numbers for each execution. And this is called randomization, and is accomplished with the standard library function isRand. And the function isRand will take the unsigned int and as a seeds functions and rand to produce a different sequence of the random numbers for each execution of the programs. And we demonstrate the function isRand in the figure. The function isRand will take the unsigned int value as the argument here. And then the conversation specifies the percent u is used to read unsigned int value with a scanful, and the function prototype for the isRand is founded in standard library header, and let's run the program several times.
Okay, in this example, I will first input a seed. And then it will generate a random number based on the seed. Okay, for example, if I input the seed as a 9, for example, then the random number will be like this. I also copy those in here. So we can check whether we indeed generate different numbers. And also we run it again. And this time I will not set the seed as 9. Maybe I set it at 4. And we can see the random number are different. For different seed, it will have a different random number. Which means that if the seed are same, then the sequence of random numbers are also the same. How does the random number related with the seed? Yes, this relationship is implemented in the random function. You do not need to know how it is generate those random number. They have some rulers and functions to generate it. However, for the user, you do not need how it generated. You just know that it will generate some random number, and when you set different seed, and yes, one seed for one sequence, and how they generate those sequence, and you do not need to know. It's a complex algorithm, in fact. For each seed, it will generate one sequence of random numbers. And when you run this rand functions, then it will take a number in this sequence. So if we set the same seed, then the sequence will be same. For example, we can set the 9 again. Then we can get the same results as before. Okay. And however, we cannot set the seed every time. So we have another solution.
And observe the results. And notice that a different sequence of random numbers is get each time the program is run. So it can provide that a different seed is sufficed. We use different seed, then we can have different randomly numbers. However, we need to type a seed for the program. But how can we to randomize without entering a seed each time? And so we can use the statement like this. We can set the seed as a timer and the type. And this will cause the compilers to read its clock to get the value for the seed automatically. and the function time returns the number of seconds that has passed since the middle light on the July 1, 1916. And this value is converted to an unsigned int and used as a seed to a random number generator. And the function prototype for the time is in the time head. So we use this function. We need also include the function. We need also include the head of the time. Now, okay. Now I will set the seed as the time as the return value of the time function. And we can see this is our result for this second. And so for next second, the result will change because the time is changing. So the seed is changing. So the random number is different. Okay. Yeah, it's an interesting example. So when you write your own program, you can first use the same seed. It will help you to debug your code. And when you write a real program, after you debug your code, you can use this seed for generate a real random number. Okay, now it's your time, and you are suggested to trying to solve this problem. And this problem will compile many knowledges we learned in this lecture. Your time, and you can use all the knowledge you learn in this lecture to solve this problem. A game of the chance. And one of the most popular games of the chance is a daisy game known as the craps. And the rules of the game are simple. And there is a player and a host. And the player will roll 2 dice, and each die has 6 faces. And those faces will include the 1, 2, 3, 4, 5, and 6 faces. And after the dice has come to rest, and the sum of the scores on the 2 upweighted faces is calculated. And if the sum is 7 or 11 on the first throw, and the player will win. And if the sum is 2, 3, or 12 on the first throw, call it the craps, and the player will lose, and the host will win. And if the sum is 4, 5, 6, 8, 9, or 10 on the first throw, and then that sum will become place points. And to win, you must continue rolling the dice until you make your points. And the player will lose by rolling a 6, 7 before making the point. And now you need to simulate this game and using the C language. Do you want to try this example, or I directly show you the code? Because in this lecture we may run over again. We may overrun again. So do you want to try this example, or I can directly show the code and explain the code for you? Yes, maybe I will show you show the code for you right now. Simple, and there is a player and a host. And so, do you want I explain this code at this time, or you can try it after the lecture? And if you have any questions about this example, maybe I will explain it in the next lecture using 5 minutes. So first, because I used this sentence, so I first need to explain what it is for you.
then you can go through this code by yourself and know the meaning of this code. If you do not have questions about this code, then maybe I will not explain it in the next lecture. So at the beginning of the next lecture, maybe I will ask you whether you need to explain this code.
We will define a function called the row depth.
In fact, I used the statements in the code. However, you do not need to use this statement. You can also write the code. So so you can forget it first and try to solve this problem by yourself. It's not impact your implementations.
It use the enumerations to enumerate by a set of the integer constant represented by the identifiers for the continuous win and lost. And the enumeration consistency will help make the programs easy to read. And the values in a enumeration will default start from 0 and are increased by the 1. So the variable game state defined to be the new type, the enumeration type, which stores the consistent state. And when the game is win, then only on the first row or on the subsequent row, the game state is set to win. And when the game is lost, so either on the first row or on the subsequent row, the game state is set to the lost. And otherwise, the game state will set to continuous and the game continues. And there are some common errors in to define the functions. Now you can find the errors in the different situations for the 4 programs.
And then you can type your answer on the chat box. This is the first one, the second one, the third, and the last one. Okay, it's a very simple error, but many of you may make those mistakes. So what's the error in in those examples? Let's see the first example. So in the first example, we do not have the function prototype, right? And we do not have int to indicate the type of x, right? So we're missing an int here. Do you have any questions for this first example? We miss a int here. And this is the second example. In this example, we do not have the function prototype, right? So we need to include the function prototype here. And this is our third example. We use the function. And this is the third example. What's the error? The prototype of the function is not consistent with the head of the functions. There is a float type. However, there is int type. So we need to change this float to int. And this is the last example. We can see that we need to return a value from this function, right? The int, the results is int. However, we define the function do not return any value. However, it actually return a value. So it will have error. So we should change this void to int. Okay. Do you have any questions for these 4 examples? So when you write your own functions, remember that the prototype and the head of the function should have the same, should have the consistent, should be consistent. And also, if the function indeed return a value, so you should use the type of the returned value in front of the function name. We will use the void in general case. In general case, for example, if we want a function help us to print something, and we will print this statement many times. And then if the function just need to print something, it do not need to return something. So we can use the void as a return value, as a return type. If we have a function and we need to write something, in these cases, we may have the void type for the return, right? For example, maybe I have a function called myPrint, right? Now this is x. We will have int x, and I will print for welcome to the myPrint function. Now and then I will print for the okay, this time this print, and then we print the x. And then we maybe call this function many times. Okay, so maybe we need to call this function many times, and if you need to use this print for function many times. It is not the same as the main function, because the main function is really returns a value 0, right? We just do not need to write this line. In fact, the main function returns 0. The compiler will help us to write this line. Okay, do you have any questions for those cases? Okay,
this is another exercise.
Is an exercise. Maybe I will let the TA to talk about this exercise, these examples in our tutorial. And you can also try it after the lecture, and the TA will explain the code and the answer. Yes, we finished our lectures before the Chinese New Year. And Happy New Year, everyone, and enjoy your holiday. So maybe we stop here for this lecture. And of course, if you have any questions, you can stay here. If you do not have questions, you can leave this meeting and enjoy your holiday. And remember, we do not have the lecture in next week. Bye-bye. And if you have questions, you can stay here, and then I will help to solve your problem. See you New Year in New Year. Okay. Yeah, maybe you can, Jason, can you pass and copy your code on the chat box? Maybe I can run it in my IDE. Yes, the void and the main void. Do you mean the void for the return value or the void for the argument for the parameter? Which void? First, and let's solve the problem one by one. Okay. Jason, I can successfully run your code. So your problem do not because of the code itself, because of the IDE and the compiler. So for the problem about the IDE, you may follow the tutorial. Do you know, you can see the recording of the first tutorial introduced by our TA Pengfei and try to create a new project, not create a new file, not create a new point C file, but create a new project and try it again. Okay, you can try it. First, look at the recording of the first lecture. You can try it now. Okay, and now I will first look at others problem. Can you give some hints about the and then for a problem of the different for the void for the Ziqiu, the void in prototype. The void in the prototype has two void, right? For example, maybe I share my screen. Do you mean the, sorry for, do you mean the void here or the void here? Void here or void here? The first, okay. The first means that our return value is void. In fact, if your function needs to return value, then you should use the type of the returned value, right? So if your function do not need to return any value, you can use void here. If your function indeed need to return some value, then you need to use the type of the value. Void means that no return is requirement. You do not need to return anything. The void means the no void, no value. For example, this void means that no argument, no parameter is needed for the main function. So if the void is here, which will mean that no return is needed. Do I answer your question? Okay, and let's see the next one. For the assignment one, the hint is for the question 6. Maybe you need to use some iteration statements. Therefore, the while or do while, you can choose the iteration statement. You need an iteration statement to calculate the number of the brothers in the first day. In fact, you can read the question many times. The code is very simple. The important hint is that you need to read the question carefully and understand what's the meaning for it. For the assignment, for the question 3, you can only use the statements list in the question, which means that you cannot use all the output statements. You can only use the statements listed in the question. Okay? In. So, right. No, you can only use the statements. Do not to change any statements. You can only use the 3 statements list in the question. Yes, cannot use like this. You can only use the statements list. What's the statement? The statement, you can only use the 3 statements. Okay. The score not only depends on the result of your code, it also depends on your code itself. We will see your code one by one, not just see the results of the code. Okay, welcome, and see you next year. Do you have any other questions? For the second part of the question 6, we need to ask the possible value of n by the C program. Yes. In fact, you can know the possible number by using the mathematics, and also you can write the C program to verify your answer. Those 2 ways. In fact, C program will help you to verify your answer in mathematics. So we don't have to explain it in C program. Yes, you can explain it in using text. However, if you use a C program, it will be a good point. In fact, we write the program to verify our idea. No, our original intuition is that you will first get the results in mathematics right. However, you can also write a C program to verify your answer. In fact, the C program can help you to easily get the answer. We use the iteration. In fact, we will need how to see. We will need the listed iteration. Not the centennial iteration because we know the iteration of the day, right? We have know the day is D. If you want to get all the scores, you just need to explain in mathematics and in the text. However, yourself, you can write a C code to verify your idea. Yes, if your environment variable in IDE is wrong, you mean the environment variable in IDE or in the math of the operating system? If your path in the operating system is wrong, then you need to restart your computer. However, if just the setting in IDE is wrong, you just need to close and reopen IDE. And King Hong, do I address your question? D is typed by user, so we need the D and use for iteration only. So we need the D and use up for the iteration only. We need the D and the N. However, the D is for the iteration and the N is the variables inside the loop will be used as a local variable. So the answer is based on the D and N. It's a function. It's a expressions based on the D and N. Maybe you can use a while the statement. So the results are based on both the D and the N, not only based on the D. In fact, it's not that complex. Maybe you need to rate. Given the N and the D, we need to output the big N. Given the no case N and D. Okay, you're welcome, Jason. Given the no case N and D, and we should find the answer for the big N. How many possible values for big N? Okay, you are welcome. If you have no more questions, maybe I will stop this meeting. In fact, we can not tell you how to solve the problem for fail comparisons to other students. However, if you have any questions about the question, we can explain you the questions. So if you have questions, you can email us, email all the TA and CC to me and see whether we can answer your question. We will try to solve your problem, but we cannot solve the question and give you the answer or something related to the answer. But if you have questions, you can email us, email all the TA and CC to me. And we will try our best to solve your problem. Do you mean the meaning of the questions or the solutions for this question? In fact, the solution is very simple. So maybe you can read this question again and think about. In fact, the format is relatively simple. The solution is, in fact, the final format for the solution is simple. So you can think it again. And if you have further questions, you can send an email to TA and CC to me. We will try to answer your questions. However, in a fair competition, in a fair menu. So try read the question again. Okay, bye-bye.